Hello, in this video I wanted to go over how to find the domain of a function. Now this is part 1 of a part 2 series. We will do 5 problems in this set that cover each potential example that you may encounter when it comes to finding the domain of a function. I've put down here 2 particularly useful pieces of information involving finding the domain. This first one says that for rational functions, and a rational function is one that is like a fraction. It looks like a fraction with 2 functions. And in those cases where it's a rational function, we do not want the denominator to equal 0. Everything is in the domain with the exception of where the denominator is 0. The second point involves square roots. When we're finding the domain of a function that is a square root, we want to find all the values that make it not negative. So those are the 2 cases here. Let's take a look at some of the problems that we're going to look at, and then we'll move on to actually solving them. Okay, here are the problems that we're going to examine. So letter A here is a rational function, and we're going to figure out what's in the domain, and this is dealing where the denominators cannot equal 0, so we'll cover that. B is a square root, so that can't be negative in there, so we'll cover how to do that. C is another square root. However, in C's case, we have a quadratic down here. Okay, so we'll talk about how to deal with that. And that'll end part 1. Part 2 we'll do D and E, which is kind of a combination, both square root and rational. So we'll get to those in the second part, but for now, let's start with A here in part 1. Okay, here's A. A is x minus 9 over x cubed minus 25x. So what we need to do is figure out what makes the denominator 0 and make sure we don't include that as part of the domain. The first step that we would have to do in these cases is going to be factoring for the most part when it comes to problems like this. Obviously, if you can't factor, then you can use a quadratic formula or other techniques that you may have learned to find what makes this 0. But in this example, we can see that this is going to be something we can factor. Let's take this denominator here, and let's actually set it equal to 0, because if we can figure out what makes this 0, then we know that those are the values that we shouldn't include in the domain. It looks like we can factor this. We can factor an x out. And then it looks like we can also factor this right here to be x plus 5 and x minus 5. So from this we see that x can equal 0, x can equal negative 5, and x equals 5. All 3 of these numbers would make this equal 0 because this is a product. So if I took 0 times all of this, it'd be 0. If I plug in negative 5 here, this would be 0 and it would make the other 2 things 0. And if I plugged in 5 here, this would be 0 and it would make everything else 0 as well. So these 3 values are what makes this denominator equal to 0. Now we want to write this in interval notation. So what we're saying is we can be any number from negative infinity to negative 5. We then can go from negative 5 to 0, from 0 to 5, and then from 5 to infinity. Okay, so that's how we would write this domain. Now what this is saying right here is that, let's just examine this really quickly. All numbers are acceptable except that are smaller than negative 5. Okay, so everything smaller than negative 5 can be in the domain, or is in the domain. Anything in between negative 5 and 0 is in the domain, except for negative 5 and 0. Then we go to 0. Again, everything in between 0 and 5 is in the domain, with the exception of 0 and 5. And then everything, with the exception of 5, everything bigger than 5 is in the domain. So that's kind of how you express this using interval notation. But the key is that x cannot equal X cannot equal these three values. So if it's okay to put the answer like this is fine. But if it asks you to put it in interval notation, this is how you would get it from here to here. All right? Let's look at the next example. Okay, in this example, we have ourselves a square root. And if we recall from the first part, that the inside of the square root cannot be negative. So what that means is we're going to take whatever's inside this square root and we're going to set this to be greater than or equal to 0. What this is saying is that 3x plus 2, it can equal 0 or it has to be bigger than 0. It can't be anything less than 0, which in other words means it can't be negative. So that's how you express that mathematically. At this point, it becomes an easy thing to solve. We subtract the 2. We get 3x is greater than or equal to negative 2. And then we divide by 3. So x needs to be greater than or equal to negative 2 over 3. Now, if we're going to write this down using interval notation, what that means is we can be, let's use a bracket here, bracket negative 2 over 3 to infinity. And what this is saying is I can be negative 2 over 3 or anything larger than that. And that's what this says in the interval notation right here. Let's get that, it's a 2. Okay, so that's how you deal with a square root situation. Let's look at the last example of this part. Okay, what we have here is the third example, letter C, where we have another square root. But this time we have a quadratic inside of the square root. Similarly to what we did in the last example, the same thing applies. X squared minus 4, that needs to be greater than or equal to 0. Now, because this is quadratic, what we want to do is factor this down. So x plus 2 and x minus 2, those two multiplied together have to be greater than or equal to 0. A problem occurs, however, that there's 3 different intervals that we must test for this particular case. Here, x would be negative 2. And here, x would be 2 to make these 0. Okay? To make these 0. If we took a look at this number line, we have to test all of these cases. We have to test here, we have to test this interval, and we have to test this interval. So we have these intervals, negative infinity to negative 2. Notice I'm putting a bracket here because of that equal to line. We also need to test negative 2 to 2. And we also need to test 2 to infinity. Now, brackets don't go around the infinities. The idea is we're going to pick some number that's inside this interval. So let's pick a test number. How about negative 3? That fits in this interval. Now we're going to pick something in between here. An easy one to pick is 0. And now we got to pick something here. 3 looks very obvious to pick. So these are our test points. Okay, so these are our test points that we've picked. I notice if I plug in negative 3 here, look what happens. If I plug in negative 3 into this, I would get a negative 1. And if I plugged in negative 3 into this, I would get a negative 5. And a negative 1 times a negative 5 would give me a positive value. So I take this number, plug it into here, and see what my sign is going to be. Let's do the same thing for 3. If I plug in 3 into this, I get 5. And if I plug 3 in here, I get 1. Well, positive 5 times positive 1, that's also positive. So this is also positive. And finally, let's do 0. 0 is the easiest one. I saved it for last. Plugging in 0 here, we get 2. And plugging in 0 here, we get negative 2. Well, 2 times negative 2 gives me a negative 4, which the sign is negative. So why did we do all of this? Well, the reason that we did it was because we want the one that's greater than 0. The one that's greater than 0, which means it has to be positive. So every one that we see a plus sign to, that goes in our answer, okay? So the answer to this question then would be this interval as well as this interval. And the way that you would write it, I'll write it up here, would be negative infinity to negative 2, bracket, union, 2 to infinity. Okay? So I didn't put it all on one line because it didn't fit there, but you get the point. We picked these two because they were the pluses. So that's how you deal with that's how you deal with finding the domain of a square root when the thing that's under the square root is a quadratic like this. Okay? Okay, that's the end of this video. In the next video relating to this, we'll do the other two examples that we showed at the beginning.